Assalamualaikum and hi everyone. Today's presentation focuses on glass in electronic device, specifically looking at its application in smartphones and displays. This topic falls under the scope of PHY351 Material Science for the Faculty of Applied Science.
Jamie! See, it's broken. It's not. Hey, don't you remember about Madam Sumaya teach us in class? About what? About glass in electronic devices in Physics 351. Which one? Shamim Abdullah, watch this.
Have you guys seen the video? Shamim's phone screen was not broken because the phone have tempered glass. Therefore, we will go through more in this video. So I will explain about introduction first. First of all, electronic devices rely on advanced material to achieve high performance and durability. Modern electronic devices require material with strong mechanical strength and high reliability, also stable for performance to ensure long-term and efficient operation. Other than that, glass is a key material used in smartphone and modern display technologies. Glass is widely used in electronic devices because it provides transparency, scratch resistance, and protection for sensitive internal components. And as you know, this case study is titled Glass in Electronic Devices, Smartphone and Display. So we will focus on the role, properties, and application of glass in smartphone and display technologies.
Alright, now we move to topic overview. First of all, glass in electronic devices is a specialized material engineered for display, protection, and touch functionality. It is designed to provide optical clarity, mechanical strength, and responsive touch performance. Other than that, glass is essential for device performance, durability, and user interaction. It enhances device reliability while ensuring smooth and accurate user interaction. And lastly, glass is widely used in smartphone, display, and emerging electronic technologies. Its application continue to expand with advancement in modern electronic devices. Alright, now I want to explain about background and history. For early use of glass in electronic display, glass was initially used in electronic devices primarily for display protection and visibility. In early stages of electronic device development, glass was mainly used as a protective and transparent cover for display. Its primary function was to allow visibility of electronic information while shielding internal components from dust and physical damage. Other than that, for development of display technologies, advancement in display technologies increased the demand for higher quality glass. With the introduction of technologies such as cathode ray tube, liquid crystal display, and later light emitting diode display, the requirement for glass evolved. Manufacturers began developing glass with improved optical clarity, uniform thickness, and better surface quality to support clearer and more detailed visual. For introduction of chemically strengthened glass marked a major breakthrough in electronic devices. A significant milestone in the history of electronic glass was the development of chemically strengthened glass. This process increased the strength and scratch resistance of glass, making it suitable for smartphone and portable devices that are frequently handled and exposed to impact. And lastly, modern innovation and emerging technologies. Recent innovation include ultra-thin and flexible glass for advanced display. In recent years, advancement in material science have led to the development of ultra-thin and flexible glass. This innovation enable modern applications such as curved screen, foldable smartphone, and next-generation display technologies highlight the continuous evolution of glass in electronics.
So at this point, we have probably all touched a screen today, whether it's a phone, a tablet, or even a smart TV. While we think of glass as clear cover in electronics, it's actually playing multiple sophisticated roles. Let's look at a couple of clear examples. Take your smartphone screen. This is an ordinary glass. It has been chemically strengthened through a process called ionic exchange, where small sodium ions are swapped with a larger potassium ions. This builds in surface compressive stress. Think of it like an invisible shield, which makes the glass much more resistant to cracks from drops or even an impact. And it's not just tough, it is also smart. Glass here acts as a dielectric insulator in capacitive touchscreen. It separates your finger from the sensor grade below, allowing the screen to detect touch through change in the electric field, almost like an invisible capacitor. So really, the glass isn't just for protection, it is an essential part of how touch technology works. And now we're moving to display, like your TV or monitors. Here, clarity and visibility are the key point here. Display glass is engineered for a maximum photonic transmission, meaning it lets through as much light as possible across the visible spectrum. But have you ever noticed annoying glare on the screen? That's where the anti-reflective coating comes in. They use thin film interference, a principle in physics where light waves reflecting off different layers cancel out each other, drastically reducing the reflection. Some high-end displays even achieve less than 0.5% reflection, making them perfectly readable in bright light. Also, during manufacturing, displays undergo high temperature process. Glass has a low coefficient of thermal expansion, so it doesn't warp, keeping millions of tiny pixels perfectly aligned. Plus, it seals up the moisture and oxygen, which is crucial for protecting sensitive material like OLEDs. And now on to what's new and next, the innovation. Recent advances are making glass even stronger and smarter. We are seeing nanocomposite and glass ceramic hybrid, glass infused with ceramic crystal, or nanoparticles. This makes it up to 4 times more drop resistant while staying thin and completely transparent. We also have an ultra low reflection glass using nano etching or advanced coating to cut glare to almost nothing. And there is a sustainability angle too. Eco-friendly, recyclable glass may be a cleaner process and recycled material, reducing the environmental impact without sacrificing the performance. But maybe the most exciting is the smart glass. With embedded sensor like fingerprint reader or a UV sensor built directly into the glass. This allows for seamless button-free design like under-display fingerprint scanner in modern phone.
Without further ado, let's moving on to the benefits and advantage. When looking at why we use glass over alternative like plastic, the main reason is optical clarity. It allows colors to stay vibrant. More importantly, from a material science perspective, glass has a high dielectric constant, which is what makes your touchscreen feel actually responsive. Unlike plastic, it also won't warp when your phones get hot. Despite its benefits, the biggest challenge is brittleness. While glass is hard, it lacks of toughness. It means it can't absorb impact very well, which is why screens still shatter. We also face a sustainability issue. Because the glass is glued to the display, you often have to replace the whole screen just for one crack, which contribute to global e-waste.
Let's dive into the future trends. The first one is rollable and foldable displays. Glass isn't thick anymore. It's now being engineered to be incredibly thin, between 30 and 100 microns, which that is thinner than a human hair. This ultra-thin glass, or UTG for short, stays durable even when it bends. So we are now seeing phones that fold in half, TVs that roll up like posters, and even wearable screens that wrap around your waist. So why does this matter? It means that our devices can be more portable, more adaptable, and save space, which move beyond the rigid, flat screens that we are used to see. Second, augmented reality lenses. For AR and VR to feel real, the lenses need to be almost invisible, which are crystal clear, super light, and perfectly shaped. That's where ultralight glass comes in. It gives us high transparency with almost no distortion, making digital overlays look like they're really there. You'll find this in smart glasses, AR headsets, even in medical tools and also car dash displays. So why does this matter? Because glass is becoming the window that blends our digital and physical worlds, making augmented reality immersive and practical. Now let's look at two more trends that are making glass smarter and greener. First, glass substrates for biosensors. Glass is naturally safe for the body. It's chemically inert and biocompatible, which means that it doesn't react with skin or bodily fluids like sweat. That makes it the perfect platform for tiny, embedded health sensors. We are talking about wearables and smartphones that can monitor your heart rate, blood oxygen, glucose, and hydrogen, all through the glass you touch every day. So why does this matter? It turns your everyday devices into personalized health tools, which will help you to stay proactive about wellness and even enabling remote care from your doctor. Next is sustainable glass composites. As we become more eco-conscious, glass is evolving to be kinder to the planet. New manufacturing methods use less energy, which cuts down the carbon footprint. The glass is also designed to be easily separated and recycled, reducing electronic waste. Plus, new composite materials make it stronger and more efficient while staying green. So why does this matter? It supports the growing demand for sustainable electronics and also helps build a circular economy where all devices don't end up in landfills but get a new life. In conclusion, in this video, we have learned the first one is glass is fundamental, which means that it's not just a cover, but it's a critical engineering material that enables touch, display, and durability in smartphones and displays.
Second, innovation is continuous. From Gorilla Glass to ultra-thin glass, material science has driven thinner, stronger, and more flexible glass, which makes foldable phones and rollable screens possible. The third one is PHY is multifunctional, which means that glass is evolving into smart platforms with embedded sensors for health monitoring, AR-ready lenses, and sustainable composites, which will shape the next generation of interactive electronics. And the last one is sustainability matters. The shift toward low-energy manufacturing and recyclable designs shows that advanced material can be both high performance and also environmentally responsible